are moving along. We are starting chapter 4 today, and our first section is just kind of, as always, our little introduction about what we're doing, and we're going to start talking about congruent figures. And what this is going to do is it's going to lead our transition from just here's a bunch of lines and angles and things to actually building things and comparing things. So of course, what we need to understand first is what does congruent mean? And we've been talking about this before in relation to like lengths of segments and measurements of angles. But now, even more specifically, we're going to talk about figures. So this is where we start combining our lines and angles and say they are figures with the exact same size and shape. So both of those have to be exactly the same. Specifically with polygons, so we've talked about polygons in the last chapter, and we're talking about any closed figures. And when we have congruent polygons, what that means is all the parts, so that means sides and angles of one polygon, are congruent to all, and we say corresponding parts of the other polygon. And again, when we're talking about the parts, we're talking about sides and angles. So in my first figure here, we have we will later learn that these are trapezoids, but we got two trapezoids, and the corresponding and congruent parts are going to be marked with these different congruency marks. So for segments, remember it's the little tick marks. And for angles, we use the arches. So for example, congruent angles, I know angle A is going to be congruent to angle E. And you're looking for the number of arches that match. So then angle B is going to be congruent to angle F. Angle C and angle G, which leaves angle D and angle H. And then we're doing the same thing for all of these segment pairs. So congruent sides would be AB and EF, BC, FG, CD, and GH. And our last one, DA and HE. And we could have gone in whatever order, and you could remember your segments could go both ways. So we could have said BA congruent to FE. And then our congruent statement is what names the two polygons that are congruent to each other. So in this case, I would say ABCD is congruent to, and you do have to go in order. So here I started with angle A, right, which had the one arch, which means I have to start my second part of the sentence with this corresponding piece. So it would have to be E, F, G, H. Order does matter in a congruent statement, because if I didn't give you the picture, you should be able to use the congruent statement to figure out which pieces match together. Okay, so even if you didn't have the figure, you would know then angle A and angle E correspond with each other because of the order they're written in. All right, so our first little practice here is going to use our two triangles, triangle ABC congruent to MNO, which immediately tells me, again, order matters. So angle A would be congruent to angle M. Angle B corresponds with angle N, and angle C corresponds with angle O. And all I did was match the angles in order from the congruent statement. So take a minute, try and solve. We're solving for the values of x and y. And a couple of equations we could set up. I know that 2x minus y, angle B, is equal to 90 because those are corresponding and congruent angles. I also know that because 5y minus 12 is between M and O, that corresponds with the 32. So I would also use the equation 32 equals 5y minus 12. And I would want to solve this equation first, 32 equals 5y minus 12, because it only has one variable in it. And so I would solve this and get about 8.8 for y, and then use that answer to help you solve for x. And hopefully you got 49.4 for x. So always start with the equation where there's only one variable you have to worry about. So using what we know about congruent figures, we have two things that are going to be helpful to us moving forward. And the first one is the third angle theorem that says if two triangles have two congruent angles, and I'm abbreviating here. So if two triangles have two congruent angles, then what that means is the third angle in both triangles each triangle must also be congruent. Right? So if you think about, if I drew my little yellow triangle like this, and then I've got a pink triangle. If I know that 2 out of 3 of these pairs are all congruent, and I know all my angles of a triangle have to add up to 180, then the third angle that was left out must also be congruent to each other. That's what the third angle theorem says. And then we also have this abbreviation CPCTC, which we are going to use constantly moving forward. So you need to know CPCTC. And what that abbreviation stands for is corresponding parts of congruent triangles are congruent. And this kind of comes from our definition of congruent polygons, but this is the abbreviation we'll use moving forward. And what that's going to allow us to do is match together angles and sides in congruent figures. So take what we've got and give the first proof here a try. And I will tell you that I put all my given information as one step to get myself started. So give this one a try and we'll see how you did. So I'm not going to rewrite all of mine, but I'm going to assume all this given information. Then I'm going to use that angle VXW is congruent to angle ZXY. So VXW and ZXY are congruent, and those are vertical angles. Remember, that's not part of the definition. You have to write it out. Then I would also know that VWX is congruent to angle ZYX by the third angle theorem. Okay. And if I want to mark everything, it would have been good if I started with marking my congruent stuff from the given statement, because that's also going to be important in the order of things. So VX and ZX. Okay. So I've got two angles, I've got all three sides. Now I've also proven using the third angle theorem that my third angle is congruent, which means my last statement is VWX congruent to triangle ZYX, because all of my corresponding parts are congruent. So CPCTC. Try out our second proof here. All right, so first thing I'm going to do is label everything from my given statement as congruent. So angle J and angle P are congruent. JK and PM are congruent. JL and PL. And L bisects KM. That's going to be helpful to know because I know bisectors create congruent segments. So I'm going to mark those even though I have to prove it. So my first statement again would be everything that was given to me. Then I'm going to say LK congruent to LM, because that'll give me my congruent segments, and that's the definition of a segment bisector. I also know now that angle JLK is congruent to angle PLM because they are vertical angles. I also now know, I'm going to mark as I go. So I've got two angles already congruent. That means the third angle has to be congruent. So angle K congruent to angle M. Again, by my third angle theorem, which sets me up because now I have three congruent sides and three congruent angles. So I know my triangle JLK is congruent to triangle PLM because of CPCTC. All right. And so that's all of our notes to get us started on chapter 4. Give the textbook work a try, bring your questions to class, and we'll keep moving forward. See you guys in class.